In this video, we're going to be solving the integral from 0 to 1 of the quantity 2x plus inverse tangent of x times sine of inverse tangent of cosine of inverse sine of x times the quantity square root 2 minus x squared times the derivative with respect to x of inverse sine of x dx. First, let's look at the nested trig functions. So we start from the innermost trig functions. We have cosine of inverse sine of x. Inverse sine of x is just some angle. So we'll set that equal to theta. Take the sine of both sides, isolating x, to get x equals sine of theta. Now we can make a right triangle with this. Sine of theta is equal to x over 1. Sine is just opposite divided by hypotenuse, so if we make an angle theta, we can make the opposite side x and the hypotenuse 1. Solving for the other side, by the Pythagorean theorem, you get square root 1 minus x squared. So the cosine of inverse sine of x is going to be equivalent to cosine of theta, and we already drew a triangle illustrating the theta, so cosine of theta is going to be adjacent divided by hypotenuse, so it's going to be square root 1 minus x squared over 1, which is equal to square root 1 minus x squared. Alright, so now we have to find sine of inverse tangent of that cosine of inverse sine of x, which we found to be square root 1 minus x squared. So this is equal to tangent inverse of something is just going to be some angle. It's going to return some angle. So let's set that equal to theta. Take the tangent of both sides. Square root 1 minus x squared is equal to tangent theta. Now we can put a divided by 1 under that and make a right triangle. Tangent is going to be opposite divided by adjacent, so we make the opposite side equal to square root 1 minus x squared, and we make the adjacent side equal to 1. By the Pythagorean theorem, the hypotenuse is going to be square root 2 minus x squared. So now we just take sine of inverse tangent of square root 1 minus x squared, and that's just equal to sine of theta. And sine of theta here is going to be opposite divided by hypotenuse, so it's going to be square root 1 minus x squared over square root 2 minus x squared. And there we go. We solved the nested trig functions. That's going to be our value for the nested trig functions. Okay. Now let's solve the last part of the integral. We have the derivative with respect to x of arcsine of x. And so that's just going to be 1 over square root 1 minus x squared. So now we have the integral from 0 to 1 of 2x plus arctangent of x times then the inverse trig functions, which we found to be square root 1 minus x squared over square root 2 minus x squared multiplied by square root 2 minus x squared, and then that multiplied by the derivative with respect to x of sine inverse of x, which we found to be 1 over square root 1 minus x squared dx. And as you can see, these cancel out to be 1, so we're just left with the integral from 0 to 1 of 2x plus inverse tangent of x dx. Integrating 2x with the reverse power rule, we get x squared, and then we have to integrate inverse tangent of x with respect to x. And don't forget to evaluate x squared at 0 and 1 and the definite integral from 0 to 1. So evaluated x squared evaluated at 1 and 0, so just going to be 1 squared minus 0 squared, which is 1. Now we have 1 plus integral from 0 to 1 of arctangent of x. For this, we're going to use integration by parts, and I'm going to use the tabular method for IVP. Set the D column to be inverse tangent of x and set the I column to be dx. In differentiating inverse tangent of x, we get 1 over 1 plus x squared. Integrating dx, we just get x. Now multiply the diagonals, so you get x times inverse tangent of x, and then add the integral on the bottom, so you actually get a minus because it's a negative, so minus integral of x over 1 plus x squared dx. Now we have to solve this remaining integral. Don't forget the 0 to 1 Now let's evaluate x times arctangent of x at 1 and 0. So that's going to be 1 times arctangent of 1 minus 0 times arctangent of 0. So that zeroes out the 0 arctan of 0, and the inverse tangent of 1 is going to be pi over 4, so 1 times pi over 4 is going to be pi over 4. So now we just have 1 plus pi over 4 minus the integral from 0 to 1 of x over 1 plus x squared dx. For this remaining integral, we can use a u substitution. Let u equal the denominator 1 plus x squared, such that du is equal to 2x dx. We have an x, but we need a 2x, so multiply the x by a 2, but also multiply by 1/2 on the outside to cancel that out. So now that we have the integral of a function in the denominator and its derivative in the numerator, that is simply going to be the integral of 1 over u du multiplied by negative 1/2. So that's going to be negative 1/2 ln of absolute value of u, which is going to be, u was 1 plus x squared, so we just substitute that back in for negative 1/2 ln absolute value of 1 plus x squared. Now we have to evaluate this at 0 and 1, so we do 1 plus pi over 4 minus, and then we do negative 1/2 ln, and then plug in 1 into the 1 plus x squared, so we get 1 plus 1 squared, which is 2, and then subtract the negative 1/2 ln absolute value 1 plus 0 squared, so that's gonna be 1. All right, and that's equal to negative 1/2 natural log of 2 plus 1/2 natural log of 1. And natural log of 1 is equal to 0, so that's going to zero out that term. So it's equal to negative 1/2 times the natural log of 2. So we subtract 1/2 natural log of 2 from that, and we have the answer. I just simplified here a bit. I put the square root inside of the natural log, ln of square root 2. And this is around 1.44. There we go, we solved it.